but we have John here with us. John Paul Humphrey-Ramos, who is going to be speaking to us about a decentralized storage protocol for large-scale commercialization. So he's with CESS, which is a cumulus encrypted storage system, and is part of the in his role as part of the marketing of this this protocol. And we're very happy to have you here, John.
Thanks, Stephen.
Graduated from MMU, which I know very well, with a degree in marketing, and is currently focusing on growth strategies to introduce the CESS into Europe, North America, and Latin America. So I'll hand over the microphone to you, John, and feel free to add to your background, and we're looking forward to your talk here. Thanks, John.
Hi, Stephen. Thanks for that introduction. Yeah, I mean, regarding my background, as you mentioned, I graduated from MMU in marketing. I've been in Manchester for about 10 years now. Prior to that, I was in Shanghai for about 4 years, and prior to that, I was in Latin America. So a bit traveled, you'd say, but also I've seen different cities and their impacts on their economies, and that's something that really inspires me behind blockchain. So let me introduce CESS to you guys. Let me just get this presentation up. 2 seconds. Let me share the screen. Okay. Here we go. Can you guys see that well?
Yes, so we can see it well, we can hear you, and we can see you perfectly.
Fantastic, fantastic. Just to let you guys know as well, the QR code in this title screen is for our webpage. There's so much more information that I could give you in 20 minutes in that website, so please visit it. We're going through lots of really exciting stages right now. So it's a pleasure to be here with you all. From behalf of Team CESS, I'd like to thank all of our community members and our supporters who are streaming this chat today. For those of you that haven't heard about us, we're a cumulus encrypted storage system, better known as CESS. And if you've not heard of us, you may be wondering, what is CESS and what we do? CESS essentially is a decentralized storage protocol that will allow for large-scale commercialization. So let's just look at the trend of the storage market. So we can see that the global storage market size currently is 243 billion, and the decentralized is 1.22 billion. For 2025, decentralized market size is expected to reach 3.49 billion. So the opportunity to take a share of that market is tremendous, and we want to pave the way for that to profit our investors, our partners, but to also create a fantastic ecosystem for our users and communities that use our project. So let's dive into the phases of CESS to better explain the project. So CESS is divided into 3 layers. The first layer is the storage and data functionality layer. This includes data processing, data storage, data discovery, display. Any data-related functionality we'll find through this layer. Following, we have the blockchain layer, which is based on Substrate. We have all the necessary blockchain components, as well as new enhancements and innovations in our incentive mechanisms and our consensus algorithms as well. We'll discuss those innovations shortly. And then we have our third layer, which is our application layer. We know many leading decentralized storage protocols at the moment. They're not doing very well at supporting large-scale commercial applications, which is fundamental really for the growth of companies and economies and people as well. The goal at CESS is to become the leading decentralized data storage that can support this large commercial storage applications and like significantly enhance how these applications can operate as well by providing an optimized data service. So it's so important for these applications that are so resource intensive to be able to be optimized at such a fundamental layer. So we're focusing on creating this great application layer with the vision of turning CESS into its own diverse ecosystem. These three layers combined are going to give us this full stack solution for decentralized data network and storage. At CESS, we have two value propositions really. And the first proposition, as I mentioned earlier, is to be a leading decentralized storage protocol with commercial usage and also scalability, because scalability is fundamental to us. The functionality layer for us is chain agnostic as well, which means it can be called through a comprehensive API by apps or DApps, regardless of where they have natively been launched. So these could be on Polkadot, these could be on any other blockchain. So when these DApps need to have a decentralized storage functionality to save their assets, this could be any asset, it could be NFTs, it could be data files, it can be ledgers, they can access the CESS functionality through this comprehensive API. Now, the second proposition, the value proposition for us is to deliver a robust and a diversified ecosystem. This will be achieved through delivering the comprehensive application layer, again, through our APIs that can support WASM smart contracts and is also EVM compatible. This is one of the improvements that we have against other decentralized storage protocols. And also apps, they can also natively launch on the CESS chain, besides just using CESS as a storage functionality, which allows CESS to have a fantastic potential to become a very diversified ecosystem. And this will provide more value, not just to our investors, but also to our partners and our users, and more importantly, to the community as a whole. Let's focus on the industry challenges that are being experienced at the moment and the solutions that we are providing at CESS through our innovations. So existing industry pain points for other storage protocols, they include possible data loss. So miners can quit at any moment, like storage miners, the nodes, which means that your data is going to be lost permanently. Lots of these protocols, they store all the data on one node. So if they decide to be no more, that's it for your data. So you've lost very important resources as well. Customers pay more for data assurance due to only having this one default copy made. Then we have slow data retrieval. This is due to no indexing and over-designed, like over-engineered proof schemes, lots of them which have time constraints bound to them as security measures normally, but it means that they are very delayed. So you can find yourself waiting minutes or possibly hours to retrieve your data. You really don't know which for large-scale commercialization, that's just something that you can't really work with. You also encounter very inefficient usage of the actual storage space. So this is due to no space pooling technologies or management. data, as I said, is only saved on one node, and large data files, they can't be saved on a node that has a small space availability. Now, this means as well that there's a very limited commercial use for these storage these protocols, and they have a limited API support for their DApps as they don't run smart contract capabilities as well. On the other hand, CESS, we have high data assurance. So 99.99%, we assure, we guarantee that your data is going to be there. We maximize our storage space through our proprietary technologies. We also provide very fast data retrieval. It's going to be down to the milliseconds level. Currently, we're at like the seconds level. This is super important, again, when you're running programs that need high speeds. You don't want to be having all these amazing technologies and programs and them be loading very slowly or experiencing lag, as we say. And this allows us to be really applicable for large-scale commercial users. Again, with the smart contracts support and the EVM compatibility. Excuse me for those messages popping up. So if we look at our first key technology, it's proof of data reduplication and recovery. So this technology allows us to obtain the high data assurance. So we utilize a few common techniques from cloud systems, and we apply them to our decentralized storage functionality. So when users submit data to be stored, the first thing we do is we replicate this into 3 different copies compared to the standard 1 copy that is normally made in other protocols. The data is then processed. So the data is going to be sliced, it's going to be encrypted, and it's going to be randomly distributed across the storage nodes for the storage. The system also needs to verify data segments periodically, and they will ensure that the data hasn't been damaged or corrupted. If for any reason this data has been tampered with or lost, or there's a fault in it, we can restore this through our proof of data reduplication recovery. As we said, we have 3 copies, and we segment each copy into different blocks, and it's sent across different storage nodes in the system. So we can retrieve them and essentially build that data back together and guarantee the recovery for our users. Now let's look at the smart space management, because this is such an important aspect of storage functionalities. So a few technologies have been combined. Again, the data slicing, which we do by simply slicing data blocks into blocks of the same size, which are stored into available storage spaces. With the use of our cloud pooling technology, CESS manages to utilize all the storage space, which is provided by the storage miners. So that means as a miner as well, you have more opportunity to put your resources to work. And you might find in other protocols that you don't have that opportunity. So you're being beaten to rewards by miners that have better capabilities to you. So the barriers to entry in other protocols may be quite high. Well, we want to create a fair system. We want everyone to be able to profit from this and create a strong and robust system. Now, imagine like a good look at the image here for other systems. So you've got the first node that's got 1 terabyte of available storage space. The second has 2, the third has 4, and the fourth has 8. So if you had a file that was 8 terabytes, in other systems, only the 4th storage node would be able to take on that job. There's no ability to pool the data from all of these nodes. In CESS, we can pool this and we distribute it as well. So everyone is going to get that reward, and it is also safer and it guarantees data for the users. Imagine a good analogy to make it, it's a very simple terms analogy, is if you were to purchase a significant amount of food, I'm sure we've all been there, and it doesn't fit in your fridge, you just can't fit all of it in. So the solution really would be to possibly slice everything up, and you arrange it into individual containers, you stack everything inside of your fridge, and you'll find that you'll not only be able to fit everything, but you'll be left with more storage space for other things. So actually, it's a very simple analogy, but it's exactly what we're doing. Let's look at now at our CESS architecture, the layered architecture. So we're introducing a layer of index functionality by introducing 2 new types of miners into the space, which is the cache miner and the retrieval miner. These will allow CESS to significantly improve the speed at which the network operates and retrieves data, because instead of having one miner do all the tasks, you've got independent roles specializing in their jobs, which allows for a much more effective processing and delivery of data. Again, CESS has shown that data can be retrieved and delivered to our clients within seconds, which is a significant improvement from the minutes, or as we said, even hours it may take for other protocols in the decentralized storage market to deliver that data to you. So if we focus on the decentralized storage layer and the content delivery layer, you'll see the 4 miners. Each of these miners as well will have their own reward scheme per se. As again, the reason we don't want to attach supply and demand to one role is also to stop that node from acting in possibly malicious ways. So let's look at the storage miner. The storage miner is rewarded by providing the following proof schemes. So they do the proof of data reduplication and recovery, which we spoke about. And we touched on the subject that they will tell the consensus miner how much space they are providing for the network, and they'll keep verifying that those files are still intact, that they're good to go. You've got the proof of space-time, which tells the consensus how long and consecutively they've been providing that storage space over a specific period of time. You've got the proof of available space, which tells the network, obviously, your available space, and this gives the consensus miner an overview of how the space is being used in the network, which is again an advantage that we have at CESS. And then we have the proof of flow, which tells the consensus miner the capabilities of the storage miner and the workflow, how that miner has been operating. So within CESS, the consensus mechanism is just here, and the consensus miners, they not only have the job of recording and maintaining a decentralized ledger of blockchain transactions, but they also maintain a recorded ledger of space usage of the storage nodes across the network due to these technologies that are this communication that is going back and forth between these 2 miners. This means the system can see the entire space availability of the network and how much space there is in total that is also being used. This means that we can efficiently slice data and deliver it accordingly to these storage nodes. So essentially, the consensus miner takes on all data requests. It turns them into the multiple copies, it slices them, it encrypts them, and it delivers it to these storage nodes. All of this happens in a TEE environment, in a trusted execution environment. Now, based on a good credit score on behalf of the consensus miner, because we do keep this record to make sure that they have been operating efficiently, some miners that have achieved this this threshold, they will qualify to be randomly selected by the system to participate in consensus and finality of transactions. Miners that achieve a good score will be, out of this group, they'll select 11 consensus miners to finalize transactions and to do block generation, essentially to earn this reward. This operation of 11 consensus nodes being selected will occur every 2 weeks. So we're also ensuring by doing this that we don't have the same miners always generating blocks, because it's important to have that aspect of it's essentially decentralization. You don't want all that to be the same miners, generating those transactions. Let's go to the next slide, which is our multi-format data rights confirmation. So here, what we do is that we take a fingerprint extraction of our sliced files. This can be texts, photos, videos, and other formats. And this fingerprint data, essentially, it's like a hash. You could think about it. It's stored in the blockchain through smart contracts. And the similarity is like SIM hash algorithms. But with this as well, we can confirm ownership of data, which again is such an important aspect these days. We have all this conversations around the world happening about ownership and royalties, and it's such an important thing for artists or content creators as well. And we can see the almost like the blood relation map between these files as well, where they're coming from. You can follow the history of that archive. So let's look now at our proxy re-encryption. So with this, it's going back to the proof schemes that we have redesigned, not time-bound as well. So what we're doing here is that we can encrypt files. Obviously, by being encrypted and by being split, nodes can't manipulate our data. They can't tamper with the data in a malicious way. Your files, you can mark these as public or as private, depending on your needs. Private data, obviously, is going to be encrypted, and you will get access to this. Only authorized users can access this via their own private key. So if we look at the client interactions of CESS, this is, again, very, very important. First, imagine the user goes on to CESS and he does a price inquiry. And the user will essentially, very different from other protocols, the user is going to inquire for an amount of space, of storage space, as opposed to paying per file, so per saved file, which other protocols use. And it's important here because it means that in other protocols, if you edit your data, you are going to have to pay for the storage of it again. And this is so important for large-scale commercialization, because that is not a viable option if you constantly need to cash out to edit things. Because in the real world, we all know that data changes, people change, businesses change, and therefore our storage protocols need to resemble the real world a little bit more. We use a dynamic pricing model as well through Origin. And this means that the consensus node, he has a real-time price data of other decentralized storage protocols. So we also guarantee our users that we are going to provide a better price for them. So it's truly a fantastic thing. Once the user agrees with that contract, he can then upload their files through the gateway, and then they will go through the process of being encrypted, sliced, and distributed. You can see here how they go to the storage nodes, and through the proof of replication, space-time, they will generate their own rewards. And then we'll have the other miners, they'll perform the retrievals for them, the decryption as well. And we'll be able to deliver very, very fast speeds. Like we said, we're aiming to be in the milliseconds level. Currently, we can provide the seconds. That's our goal, really. The use cases for this are really countless. We all need data storage. It's a fundamental to any enterprise. We're finding at the moment like we can create a very secure asset trading for NFT ecosystems through data right protection and the assets traceability. It's a decentralized network drive. Again, the dynamic and competitive pricing provides unlimited scalability through fast data processing and very comprehensive and user-friendly APIs. Again, we have that smart contract capability, and we're compatible with EVM, which is very important to be able to cater for a wide array of potential users. Our use cases metaverse and GameFi as well. So the commercial response times for metaverses and other DApps, as I mentioned prior, like these are very resource intensive programs. Now, a metaverse as a whole, we know it's such a complicated real time application. You really need to be able to process the specs of these programs very, very quickly. Let's imagine we have a metaverse with a million people in it. We really need to be able to deliver the expectations of these users in order to be able to scale all of these businesses. We want to provide a comprehensive streaming media platform. We envision real-time artist collaborations, which is absolutely fantastic. We want to be able to be the base of next generation streaming services. We want to be able to stream live from our blockchain. All of these things are super exciting. This is just an overview now of the roles, the miners, and the incentives. So again, we have the storage miner, which provides all this space for the network. They provide all their proof schemes. The consensus miner, as we said, with all these very important roles that they have of recording and maintaining ledgers for blockchains and transactions, and the scheduling space usage of the nodes. For staking, the profits, again, they're proportional to the staking allocation. and we've got the dynamic incentive model as well. So these are going to be at the top, our 4 miners: the storage, consensus, retrieval, and the cache. So at CESS, we've got like very
awesome, John. We're just coming up to the hard break here. If
okay.
Couple minutes, and
yeah, I'm about to wrap up.
Very cool.
So,
I know
sorry.
you've got your eye on the clock, so it's good.
It's so hard. I wish we could speak about an hour about CESS. But yeah, so we've established strong partnerships with Polkadot ecosystem. So CESS is building a storage palette for Polkadot to provide that storage functionality to over 400 projects now to conveniently use our functionality. CESS won first place in the Polkadot Hackathon 2021. Twice we've received a Web3 Foundation grant. We're part of the Substrate Builders program, and we are part of the Web 3.0 bootcamp in China as well. Also, it's very important, about to wrap up, CESS wants to bridge as well Web 2 application and traditional enterprises, not only Web 3.0, so we can also cater through our just the storage functionality for the needs of data privacy. This can be scientific research, medical research, legal, supply chain manufacturing, content creators as well. This is a quick overview of our roadmap. I won't go into it too deeply. I'll just let you guys know that we've just launched our testnet. So please have a look at that. Here is the link to our Discord channel, where you'll find a lot more information about it. And again, if you guys have any questions at all, please reach out to our communities, through our channels. We're more than happy to help. We want to share our knowledge with everyone in the ecosystem. Thanks a lot.
Thank you, John. That was amazing. That was a very complete and detailed journey into what CESS has become, where it started, and what it's trying to solve. And I had a few questions, but I think we're really getting close to the time for our next speaker. But if you could put in your Telegram handle into the chat, then we can follow up. Various people that might have questions for you can connect you or contact you directly.
I'll put all our handles in so you guys can get in touch with us.
Okay, that is excellent. Thank you very much for your engagement and your transparency in this project. It looks just solid to me. I'm not a highly tech person, but the whole storage space is becoming a major issue.
It is.
So I'm very happy to see that you guys are working on solving this in a decentralized way, where it's safe and transparent and with guaranteed recovery, which is, I love that aspect of it. So thank you again, John.
Thank you for having us today.
Thank you.
Thanks. Bye.